How's it going, everyone? My name is Benjamin Caruso, and this is my project on text classification of agricultural interviews. Essentially, I'm working with a research team here at UVM who does food science and nutrition research, and their goal is to explore how farmers and policymakers slash experts around Vermont and Maine discuss topics like agricultural land use, climate change, the environment, and more. One of the areas of interest is how farmers and experts differ in how they speak on climate change. And so that's what I'm focusing on. My goal is to basically convert the unstructured text of their interviews to a supervised learning problem, where I'm essentially classifying a passage of text as spoken by an expert versus a farmer. And the passage of text is going to be very related to climate change slash environmental issues because, as I said, the whole goal of the project is really to determine like who's speaking and how they talk about it and how they differ in how they talk about it. Now, this is sort of a twist on a classic text classification problem where you're just doing topic modeling or something like that. This is kind of unique in that I'm trying to classify the speaker of the text, and I'm trying to use that and the nuance of the language and semantics actually to will be very important in determining how I'm actually classifying these speakers. So the reason I'm interested in this is because I'm super interested in natural language processing in general, and text data is so prevalent now in the world that I think this is super valuable skills to have. The interviews were given to me in the form of Word documents, just .doc files. And what I had to do was I used the Python docx module, which is a really convenient library I found online, to process them, convert them to docx files, read them into Python, and I then did some data processing using the tab separation. As you can see on the left, the tab separation and the labels associated with each block of text. I basically isolated the interviewee and interviewer labels, the blocks of text, so to speak, so that I would be able to just get a huge block of text that you can see on the right that just pertains to what the interviewee, in this case a Vermont farmer, said. So these were read out as four separate text files, one being Vermont farmers, one being Maine farmers, another being Vermont experts and Maine experts. I separated in that way to hold counting and obviously to keep track of my target labels. From here, I used spaCy, which is a very popular text preprocessing library, to continue to actually convert this raw text into a supervised learning problem. And how I did so was I first just used spaCy's NLP pre-trained model on the entire text corpus of a certain one of the four text files. And what I was able to do there is I was able to just sentence those. And it basically split on a period and get a huge list of sentences. I then just did a few pre-processing steps on the sentences, such as removing punctuation and lemmatizing the sentences. I removed stop words because I wanted to keep them in for later, but I ended up removing them later in the count vectorizer. So the match terms that you see, the climate change, climate, etc., those are the terms that I felt best represented the agriculture and climate change scope that I was really going for. And so what I did was I found sentences that actually match on one of those terms. So one of those terms is included in every single sentence in the match terms data frame, and each sentence was obviously said by either a farmer and or expert. And therein lied the data frame, the supervised learning problem that I was then going to solve. Each of those sentences essentially has something to do with the environment and climate change because of how I use the match terms. And my goal is to then classify them based on the language used and the word used, and see if I can really see if a model can notice a difference between which one is speaking. Now, as a baseline comparison, I also made a data frame of just all the sentences said by by experts and by farmers, and so that's the one below. And that's just every sentence. There's no match terms there. There's no other special processing done. They're both subject to the same pre-processing pipeline, but the total data is just everything. Now, the data that I actually used for the modeling, I made sure the resulting data frames were of equal size distribution as indicated. So that means for the match terms, it's about 400 rows, and they're equal distributed between farmers and experts. And so I did the same. I took the same subsample from the total data in order for the comparisons to be legitimate. Now, as far as the modeling itself, I started with a very simple bag of words count vectorizer using unigrams, and I removed stop words as well using this counter vectorizer. And I did this because it's a pretty simple baseline model that does an effective job of really getting at the point and isolating the words used, and that's essentially what I started with. Logistic regression was the first model I chose because it allows for interpretation of the coefficient magnitude, which, since I'm focused on which words are being used to classify which speaker, that's obviously super important. I also use random forest for the same reason, as a feature importance attribute is very valuable and allows me to graph which words were used for all the splits. And finally, I tried SVM because it's good with small data sets and high dimensional data sets, which my data set certainly qualifies as small, as being about 400, not even 400 terms. And the sparse matrix that results as a count vectorizer fit and transform is pretty high dimensional. So my results were just as shown. Logistic regression, SVM, and random forest all performed very similarly, where in terms of accuracy, because I chose accuracy because the distributions were identical, as I said, and I felt that the accuracy got the best overall metric for determining which one really performed better. And essentially what I found with the hyperparameters shown, which were chosen using grid search and just a little trial and error, I found that the match data actually performed way better. The match accuracy on the same exact model pipeline trying to predict the accuracy or trying to predict the class of the data with the match terms performed much better than just the general data. And this can be due to a lot of reasons. This obviously provides evidence that the match terms allow the model to classify a speaker better, but it also could be due to noise in the general data set, and it could be due to some other factors I haven't seen yet. So obviously none of these results are final, but it gives me a good indication that the accuracy I'm getting and the results I'm getting show me the match data, and those match terms actually improve model accuracy and actually allow the model to do a better job of classifying the speaker. I did perform a permutation test on the logistic regression model as just sort of a sanity check, and as you can see, I got fairly similar classification scores with fairly significant but not very significant p-values, and so further analysis will have to be done before I can really draw a significant conclusion from these models. Now, as far as the results I was able to find, I was primarily looking at the words used because since I used Bag-of-Words model, that's really the most information I can get. And I found expert use words such as farmer, impact, information, ecological, some of which makes sense. The expert talking about a farmer makes sense, and farmer mentioning chicken is kind of a funny example, but it makes more sense for a farmer to talk about it than an expert. So that provides some indication, but these words aren't really conclusive on their own right. There's not much I can really interpret from this, but it serves as a good jumping off point for going to the next step and improving on the model. And going forward, I would focus probably more on word embeddings, and I would probably use a neural network for feature extraction that would actually perform on my actual data set. Instead of just using a pre-trained model, I would want the neural network to actually extract features from the data that I'm working with. And so I wasn't really able to do that for this project, but going forward, that would be my aim, because I think that that's my limiting factor. I think that making those features a little more powerful, a little more nuanced, and able to capture the semantics that each speaker uses, I think will really improve model performance, although probably at the expense of interpretability. Furthermore, I would continue to do further statistical analysis of the results I got. Obviously, I showed better accuracy with the match data, but there's still a long way to go, and there's still plenty of tests that need to be performed before I can be really confident in those results. This is bibliography, the sources I used. Thank you very much for listening. Hope you have a wonderful day.